Wheel brake is an important component of the automobile braking system. Its performance will directly affect the braking effect of the vehicle. Different types of automobile brakes are not the same. This lesson led us together on the wheel brake for systematic study. There are 3 learning objectives for the course, namely, familiarize yourself with the role and types of gearboxes, knowledge of the construction and operation of drum brakes, knowledge of the structure and working principle of disc brakes. We will learn today's content through the following 3 parts. 1. Definition and classification of brakes. Definition of brake. Brake is an actuator in the automobile braking system through the friction of the friction element, the formation of braking torque, to produce the braking force that prevents the automobile from traveling, to overcome the inertia of the automobile traveling, so that the automobile quickly decelerates or stops. Types of brakes. 1. Drum brake. Relying on the brake block on the brake wheel pressure to realize braking. The rotating element in the friction vise is the brake drum, the working surface of which is cylindrical, and the fixed part is the brake base plate and brake shoes. To that disc brake, controlled by hydraulics, the rotating element is a metal disc, commonly known as a brake disc, working in end face, which is clamped from both sides by friction elements to generate friction to form a braking effect. 2. Drum brake. Structure composition. Drum wheel brakes are mainly composed of brake drums, brake shoes, brake wheel cylinders, return springs, friction pads and support pins, brake base plates and other components. Categorization. Drum wheel brakes can be divided into 3 types based on the force on the brake shoes: lead follower type, double lead type, and self-increasing type. The double collar brake can be divided into bidirectional double collar brake and double follower brake. Self-increasing force can be divided into unidirectional self-increasing force and bidirectional self-increasing force. 1. Leading trailing shoe brake. When braking the front shoes open, the direction of rotation and brake drum rotation direction is the same, known as the leading shoe. The opposite after the shoe is called from the shoe. The tangential force on the collar shoe results in the collar shoe being pressed more tightly on the brake drum, indicating that the collar shoe has an increasing momentum effect. In contrast, the slave shoe has a decreasing momentum effect. 2. Leading shoe brake. In the car forward braking, the 2 brake shoes are collar shoes. When the car reverse braking, the 2 brake shoes are from the shoe, resulting in forward braking efficiency. Reverse braking efficiency is reduced. 3. Dual leading shoe brake. Whether the car forward brake or reverse brake, both brake shoes are collar shoes, belonging to the balanced brake. For trailing shoe brake, both brake shoes are slave shoes when the car is moving forward. Forward braking efficiency is lower, but its efficiency is less sensitive to changes in friction factor. It has good braking efficiency stability. 5. Servo brake. In the car forward braking, the use of the front hooves to promote the rear hooves, so that the total friction torque increases, play the role of automatic force. Reverse braking, the rear hooves are not subject to the promotion of power and does not act as a brake. 6. Uniservo brake. When a car is braked forward, the 2 brake shoes open up under the action of the actuating force F and press against the brake drum, so that the total friction torque increases. When a car is braked in reverse, it has the same self-increasing force as in forward braking. Principles and processes. The mutual friction between the fixed and rotating parts is utilized to stop the rotation or tendency of the wheel to rotate. 1. When not braking, there is a gap between the outer circular surface of the friction pad and the inner circular surface of the brake drum, allowing the wheel to rotate freely. When braking, step on the brake pedal. The push rod pushes the piston at the brake master cylinder forward. The oil pressure of the brake fluid rises and enters the brake wheel cylinder through the oil pipe and pushes the piston at the wheel cylinder outward. The wheel cylinder piston pushes the 2 brake shoes outward, so that the friction plate on the brake shoe is pressed on the inner surface of the brake drum, generating a friction torque opposite to the direction of rotation of the wheel. 3. To release the brake pedal. Under the action of the return spring, the brake shoe returns to its original position, while the clearance between the shoe and drum is restored, and thus the brake is released. Advantages and disadvantages analysis. 1. Advantage. Drum brakes have a good self-braking effect and are strong, and are mainly applied to the rear wheels of large vehicles and some small cars. Lower cost. Drum brakes were the first to be used in braking systems, with a lower level of manufacturing technology. 2. Drawbacks. Brake pads are sealed inside the drums, and where debris affects the contact surface and therefore the braking performance. Poor heat dissipation performance. Parts are easily deformed at high temperatures, which reduces braking efficiency. Regular gap adjustments are costly to maintain. 3. Disc brake structure composition. Disc wheel brakes are mainly composed of calipers, pistons, brake friction pads, brake linings, brake discs, mounting brackets, and so on. Categorization. Disc brakes can be divided into caliper disc brakes and full disc brakes based on the structural form of their fixed components. Full disc wheel brakes. A few heavy-duty vehicles use them as wheel brakes. Caliper disc wheel brakes, commonly used in cars and trucks at all levels. According to whether the brake caliper is movable, it can be divided into fixed caliper disc wheel brakes and floating caliper disc wheel brakes. 1. Fixed clamp disc type. The caliper body is fixedly mounted on the axle. It can neither rotate nor move from side to side, and the two pistons are located on each side of the brake disc. 2. Floating fixed clamp disc type. The caliper body is connected to the axle by means of a guide pin and can be moved axially relative to the brake disc. The caliper body is equipped with a hydraulic cylinder only on the inner side of the brake disc, while the outer brake block is attached to the caliper body. Principles and processes. When braking, step on the brake pedal. The push rod pushes the piston at the brake master cylinder forward, and the oil pressure of the brake fluid rises and enters the brake caliper through the oil pipe. 1. Fixed clamp disc type. Brake fluid enters the two connected hydraulic cylinders in the caliper body through the inlet port and presses the brake blocks on both sides to the brake disc, which is fixedly connected to the wheel, thus generating braking force. 2. Floating fixed clamp disc type. Brake fluid enters the brake caliper through the inlet port, which pushes the piston and friction plate to move to the right and presses onto the brake disc, and the caliper body as a whole moves to the left, so that the friction plate on both sides presses onto the brake disc, thus generating braking force. Advantages and disadvantages analysis. 1. Advantage. Stable braking efficiency. Simple structure, easy maintenance, low cost. Fast response, high-frequency braking, can be used with electronic systems to improve braking performance. 2. Drawbacks, higher manufacturing requirements, high cost, high wear and tear of friction pads and discs. High brake fluid pressure, booster required. In this course, we focused on studying drum brakes and disc brakes, two types of vehicle brakes, and understood their classification, principles, and working processes. We believe you have gained some understanding of these two types of brakes, and we hope you can consolidate the content on your own to lay a foundation for learning the electronic system at the braking system.